Good afternoon. Today we're going to be talking about the limits at infinity of powers and polynomials. Meaning we don't have any fractional things. Everything is a power or a polynomial. Alright, so first off, we have this generic name for a polynomial. It's a little bit awkward to understand. Essentially, it's just a polynomial in standard form, where you have generic coefficients a's. They could be different, they could be the same, and you have your x, and again, the leading term and leading coefficient is where we would have the largest power, and that's all we really care about here. So that's what we're going to be focusing on, is that leading term and that leading coefficient. Alright, so let's take a look at some of these different little rules that go along with it. First off, the limit as x to an exponent and x approaching negative or positive infinity. So essentially we're looking at a negative or a positive infinity raised to a power of n. But n is an even power. So that means power of 2, power of 4, power of 6. So just think about that for a second. If I have a positive number to an even power, I get a positive answer. If I have a negative number to an even power, I get the same positive answer. That's why, again, if it's even, we always get the same answer. X to any power would equal infinity if the power is even, no matter if you're being a negative infinity or a positive. So again, it gets a little awkward at first, but I think a couple of practice trials, the work, just like everything else we've done in this chapter, the work is easy. Just getting used to new symbols, new notation, new thought processes. Alright, so next line here. What is happening if the limit approaches positive infinity or negative infinity, but this time our exponent is odd. So that's what's different. We have an odd exponent. So for example, we could have an x to the third power. Alright, so if we're looking at the limit as x approaches infinity, that would be something like infinity to the third power, which again would be infinity times infinity times infinity. Since they're all positive, you'd get a positive infinity answer. But if I were to switch that to a negative infinity to the third power, that's negative times another negative times another negative, which would give us a negative infinity answer. So that's what that line is saying, is if the power is odd, and again, all about your leading term, all about that highest power. Alright, if that highest power happens to be odd, then it depends. We could have two different possible answers. We could have a positive infinity or a negative infinity, depending on what we're plugging in. Alright, next off, anytime you have a negative power. Negative powers are essentially things that could have and should have probably been written in fraction form. But anytime you have an infinite negative power, it's going to be a limit of approaching 0. Because essentially, again, what you're looking at is this. What is 1 over infinity? Well, 1 over infinity is 0. It doesn't matter if it's positive or negative infinity, because there's no such thing as negative 0. So again, you get the same answer for both the positive and negative. That's where you're getting that little symbol in there with the plus and minus sign. Again, that means that it's the same answer for both the positive and the negative version. And again, that's because we've got that infinity in the denominator, meaning you're just always getting closer and closer and closer to a terribly small, tiny fraction. All right, then last but not least, what happens if, again, we're looking at the limit of positive or negative infinity, and it is got a out front. We've got that extra term. The other ones, the first three rules, we didn't have that coefficient out front. So that coefficient can definitely change something. If that coefficient is positive, then it's not going to change anything. But if the coefficient's a negative number, it will reverse the direction of the answer from being positive to negative or negative to positive. So let's just take a look. Let's try an example or two. All right, so we've got to find the value of limits as x approaches positive and negative infinity for the following. So let's do the first one. let's look at it as x approaches the positive infinity portion. And again, with these, the only thing that really matters is that leading term, that leading coefficient. Because again, as x approaches infinity, that term is going to be much, much larger than all the other ones, kind of making them obsolete. All right, so if that were to happen and we were approaching positive infinity, essentially that means we're going to have 3 times infinity to the 4th power. And again, since it's an even power of 4, we know that that's going to be a positive infinity. And if I'm taking a positive 3 times a positive infinity, I will get positive infinity. So that would be my first answer to part A. Now let's look at part A, the limit as x approaches negative infinity. For the same thing, we're looking at that leading term and leading coefficient. So that's going to be 3 times, well, anything with a positive, or sorry, an even power, doesn't matter if it's approaching negative infinity or positive, it's infinity. And if you're not sure, go back and look. Anything with an even power will always approach positive infinity no matter what. Alright, so once again we have a positive 3 times a positive infinity, which is going to give us another positive infinity answer. Alright, let's try part B now. Alright, so for part B, let's first off find the limit as x approaches positive infinity. And again, all that really matters, as long as it's in standard form, is that leading term and leading coefficient. Alright, so for this one, as we're approaching positive infinity, it gives again negative 2, and then x to the 3rd, but x approaches positive infinity. So again, here we are in the second one. We have odd, alright, but x is approaching positive infinity. So if you have an odd power, x approaching positive infinity, that means infinity. But we're multiplying that infinity times a negative number. And anything, a negative times any positive makes a negative. So we get a different answer. We get a negative infinity. That leading coefficient flipped it for us. Now if we're looking at x approaching to negative infinity of the same thing, same leading coefficient, we get negative 2. Now let's go back and look at what happens with odd powers approaching negative infinity. Right there. An odd power, x approaches negative infinity, we get a negative infinity answer. So this is going to be a negative infinity answer. Now when I take a negative infinity answer and multiply it by a coefficient that's also negative, negative 2, I get a positive infinity answer. So again, everything's going to be all about infinities today. And again, it's not hard work. I mean, the work was simple. There's not much calculations. It's all just kind of understanding what's happening and understanding the concept. All right, you know how to get a hold of me if you need any extra help or want to check any answers. And again, please feel free to do that. I'm just sitting at my desk waiting for you. So let me know if you need any help. Good luck.